Okay, so here is the pre-process of the type of dataset, which is the DNA methylation and the gene expression dataset, which is both are multi-omic dataset. Okay, so the first step is to import the required libraries. For this one is to mount our Google Drive into the Google Colab. So the next is to read the raw data. Okay, so for the read the raw data, we will read both DNA methylation and then gene expression dataset. So next is to checking missing value inside the dataset. So you can see for checking missing value, we will use the isNull.values function to check whether there is missing value inside the DNA methylation and gene expression. So here, based on the result, we can see that both give a false output, which is indicate that there is no missing value inside the dataset. Okay, so next is to transpose the data. So the purpose of transpose the data is to make us easier to understand the dataset. So in here we can see that each patient ID, this is the patient ID. Each patient ID has this value of METI. The same goes to the gene expression, and then we will use the ex dot t to transpose the dataset. Next, we will rename the unnamed column to patient ID. As we can see here, there is no column name for the patient ID. So we will rename the unnamed column into patient ID. So we will use the rename to rename the unknown to the patient ID. So we can see here that the unnamed become the patient ID column. The next, this will same goes to the gene expression data. And then next we will move to the dataset redundancy. So you can see that both methylation and gene expression has no duplication or redundancy inside the dataset. And next, one of the most important thing for multi-omics is to integrate the data, which is for this research, we will integrate DNA methylation and then gene expression dataset. We will be using the pd.merge function to merge DNA methylation and gene expression based on their patient ID. So in here, when we merge the dataset, we can see that there is a missing value for the merged dataset. So we will I choose to drop the missing value inside the dataset because it will more easier and faster. So after we will use the drop now function to drop the missing value. So and then next we will move to the pre-process, which is I choose the normalization for the dataset. So here we will use the normalizer, which is we will use all this code to normalize our dataset. So here we can see that all the dataset is normalized. Okay, is normalized into the same type of format. Okay, next we will read and understanding the our clinical data, which is we use the same function as the previous DNA methylation and gene expression, which we use the pd.read to read the clinical data. So why we need to read and understand the clinical data is because we need to know our sample type. Okay, this one we need this particular column because we need to know whether our patient ID have primary tumor or solid tissue normal. Okay, so for the step, same goes to the previous. We will rename the um for this sample ID to the patient ID, and then and here we replace the uh, okay, this one the patient ID for this one is they use the dash. So we will replace the dash into the dot, so it will be easier for us for the next step. And then Okay, so for this one, okay, so we do another step to remove the the index beside the data set. And then after that, we need to merge the multi-omic dataset before with our clinical data, same based on their patient ID too. So here, after we merge, so we can see that here they already include the sample type of the patient ID. So here we can see that the multi-omic has been merged with the sample type. And the next is we convert the sample type into a number. So we can see that here we will use solid tissue normal and primary tumor. So here we will convert the solid tissue normal into 0 and then the primary tumor into 1. And you can see that the result is changed. And then next, as you can see here, when we merge the dataset, there will be a missing value. So we will drop the missing value by using the same function, which is the drop now. And then you can see that there is no missing value here. Okay, and then after that, we will convert the merged dataset with the clinical data into the .csv file and then save the file into the Google Drive folder. So it will be easier for me to use the dataset for the next step of feature selection, which is the Boruta feature selection. Okay, next we will move to our first feature selection, which is the Boruta feature selection. So first, to use the Boruta, we need to install our Boruta package. So we use the pip install Boruta to install the Boruta package. And then next we will import the required libraries inside our Google Colab. So here we import the libraries. And then we can see that there is a random forest classifier here. Because this is because the Boruta used the random forest classifier for its feature selection. Okay, next we will mount the Google Drive into the Google Colab. Here mount. Okay, so here to load. Next we will load the previous merge dataset from the preprocess step into the Boruta Google Colab. So here we will load the dataset. It will take um, time to load the dataset because the dataset is big. So here after we load, then we need to drop the patient ID because when doing the proto process, it doesn't need the patient ID, so you just need the value in order for the Boruta to come out with the output. So we need to drop the patient ID and then later we will merge the patient ID back into the dataset. So here we need to split the data into X and Y. This is for the random forest classifier. So here for the X, we will drop the sample type because the X is for only for this value, the value for the merge dataset and not for the sample type here. So, and then the Y is for the sample type. Okay, so X is for the value and then Y is for the sample type to indicate whether it is 0 or 1. Okay, next, here is the function to split and trash the dataset. So here, and then for this dataset, I choose the 0.3 dataset. It means that the X will be 0.7 and then the Y, which is the test size, will be 0.3. Okay, next, this is the random forest classifier. Okay, so we will use the random forest classifier for the for our dataset. So here we will use the job -1 class weight balance and then the max depth is 5. And then the fit selector, this will be the function for the Python or for the feature selection to select the feature inside the dataset. So we use the Boruta here, Boruta function from Boruta package. Then next is the fit selector before will fit the um, X and Y into the feature selector. So then it will continue with this type of process, which is this type of process is take a long time to complete. So here it will be around 100 iteration. So at the end of the process, it will show that okay, here. So it already completed the iteration, which is 100 iteration, and then it confirmed that there are 309 feature has been selected, and then the rejected is quite big, which is the 25,157. Okay, next we in order to easy for us to see the output, we will print the selected feature. So here we can see that the selected feature is 309 features has been selected. So okay, all the section is for us to list our rank of the dataset after the Boruta feature selection. So we will print all the feature selection, all the features inside the dataset. So here we will use the fit selector ranking to rank our dataset. So here we can see that the output is okay. The from 0 to 0, from number 1, from index 0 to 308, all the rank is 1, which is the 309 features is the top features inside the dataset. So that's why it only select 309 features. Okay, so this is the to print the list of features inside the dataset. Okay, next is the Monte Carlo feature selection. Okay, so basically, the MCMS for this research is run inside the R Studio. Okay, so first, for step 1, we need to install the RMCFS package into the R Studio. So here, this is the code for the to install the RMCFS inside the R Studio. So this is the process. Okay, next for step 2, we will need to read and view the dataset. So here, the first line is we read the dataset. So here we use the read.daily function to read our dataset from our laptop. And the next, the view is we need to view the dataset. I mean, we need to visualize our dataset. So here is the visualize of the dataset. So here, as we can see, there is an extra column which is X. So for the next step, which is the step 3, this is where we remove the unwanted column in dataset, which is the X column from the previous one. Okay, we need to remove that X column. So we used to select and then remove the X column. So here we can see that there is no X column anymore. So for the step 4 is to define the MCFS function. So here, first we define our result, and then we use the MCFS function, and then next we use the MCFS function. The next is we need to print the result. So when we print the result, it will give us this type of output, which is it will tell us there are top 111 features has been selected for the MCFS, and plot the result as a bar graph. So here you can see that the red one is the important, and then this one, the gray one, is not important. Okay, for the next feature selection, which is the MRMR. Okay, so first we need to install the MRMR package, which is we can next we will need to import the selected features, selected libraries into our Google Colab. So here also we import the MIMR from the MIMR package. So the next one is we need to mount our Google Drive into our Google Colab. So the next one, we need to load the dataset. We need to read the dataset. We need to drop the patient ID. And then so for the data, so for the here we will define the X, Y, and K. For the X is it will indicate all value except for the sample type, while Y will indicate the sample type value. And then for the K, so here the K will indicate how many top features that we need. So here we already choose we need top 20 features for this MRMR. So here we will define our function by using the MRMR classify. Okay, so here in this process, this is the process to calculate the score of each features. So here we can see that it calculates the score. Here we will print the score. So here it will give us all score for each features. And here we will print the selected 20 features for the MRMR. So here they are top 20 features for MRMR. Okay, next classification, which is in this research we will be using SVM as our classifier. So here first we need to import our required libraries into this Google Colab. And then next we need to import or mount our Google Drive into this Google Colab. So next we will load our dataset. So again, next, like always, we need to drop the patient ID too. Okay, so here is where we define our X and Y. So the X here is the all value of the features except for the sample type, while the Y is the value of the sample type. So for Y we only need sample type value. So and also here we will be using trend and test our X and Y. So here we will be using the test size 30%, while our trend size will be 70%. So and then so here is one of the important part, which is we need to import the SVM. So here we will import SVC. So SVC is also similar with the SVM. So we will import the SVC from the scalar.svm, which is the SVC is inside the SVM. So here we will be using kernel RBF, and then also we will fit our X trend and Y trend into our SVC classifier. So here is the process and the detail of the SVC. So after that, we will print our confusion matrix. So for the confusion matrix, we'll be using the Y-test and Y-print. And then this is the confusion matrix. So to calculate the sensitivity, these are the formulation of the sensitivity. And then we print the sensitivity, and then this is the formula for the specificity. So here we can see that the sensitivity has 1, while the specificity has 0.991001 as its specificity, and then it can be considered high. And then for the accuracy, since the previous model used LOOCV cross-validation, so we also use the same cross-validation, which is the leave one out cross-validation. So here we will use the leave one out function. Okay, and then at last we'll see that our accuracy is 98.25%.